Yeah, just put those down over there. No, it's okay. Just no, stack it up. Stack it up on that other box. Listen, I got to do something here. So yeah, just figure it out and then leave. Sorry about that. Just had some delivery. Let's go ahead and take a look at planes. So by a plane, I don't mean like an airplane. I mean a plane like a sheet of paper. So how are we going to represent this in 3D? What we're going to do is we need what's called a normal and then a point in the plane. Now, once again, I'm not going to go over the gory details of this, but let me just point out that, okay, so here's what I'll do is I'll represent the plane kind of like this. So imagine that this is a sheet of paper just floating in space up there. And then here's the normal. The normal is actually perpendicular to every vector in the plane. So you can think of it as perpendicular to the plane, but it's literally perpendicular to every single vector in the plane. And so you know that if you have two vectors that are perpendicular, their dot products will be, or their dot product will be zero. And so that's where this standard equation for the plane comes from. You take this normal, and then you take any vector. So this is, by the way, the point P, and we'll just put a Q here. And this dot product between the vector, the normal, and this vector PQ will be zero. And you can see hallmarks or the echoes, if you will, of the dot product right here. Here's the first component of the normal. And then this would be the difference between P and Q. And then you have the second component, and then the difference between the Y values, and then the third component. But the main thing that you should know is that this is the general form of a line, and and that the in is called the normal to the plane. Now, something that I can't stress enough is that when you're dealing with planes, it's different from dealing with lines. So a plane is going to have a single equation. You have a single equation for a plane, whereas a line is three equations. So this is a plane, and this uh, a t y is equal to, sorry, I had to think for a minute here, z is z1 plus ct. So this is a line. Now, despite the fact that you're going to be doing a bunch of exercises with this on WebAssign and for me on paper, you're still going to get this mixed up on the next test. Well, not all of you, just one or two of you. And it'll be discouraging for you, but also for me. So try not to be that person and try to keep these straight. Anyway, let's go ahead and do some practice. So lines, you actually have three components for a line. Planes, a single equation. Okay, so let's do some planes here. Let's find an equation of a plane that's perpendicular to this line and passes through this point. So remember, to find a plane, we need a point and a normal. So the point we've already got right here. That's the point. And to figure out the normal, notice that it's perpendicular to this line, which means it's normal to the direction of that line. So we just need to figure out the direction of that line. Well, the direction of that line can be had by taking the components of these coefficients of t, and there is no t here, so I'll just put a little highlight there to remind myself that there's a zero. And so my normal is going to be the vector 3, -1, 0. So now I've got a point, I have a normal, and now I'm just going to set up my equation. It's pretty straightforward. You do the normal, 3 times x minus the point, plus the normal times the y component of the normal, times y minus the y component of the point, plus the z component of the normal times z minus the z coordinate of the point. And all of that should equal 0, and it's all behind my head. Sorry about that. Let's see, can I make it higher? There it is, but now you can't see it all. It's off the screen over there. Well, anyway, I did my best. Here, does this work to shove it higher? No? Well, anyway, let me just clean this up. Move my head out of the way. Clean it up. You get 3x minus y equals 0, because that's 0 times all that mess. So there's my plane. Okay, great. What about this one? Find the equation of a plane that goes through 3 points. So here you have to imagine you have these 3 points that are in this plane. So it's like a piece of paper. That's what I'm trying to draw here. It's like a piece of paper floating out here, floating up there. And then this piece of paper has 3 dots on it. Anyway, I need a normal to the, you can pick any one of these to be the point. And so we might as well pick the simplest one. That's the easiest one. But I need a normal. And so to get the normal, what I'm going to need to do is I'm going to find 2 vectors that are in this plane, and then I'll do the cross product of those 2 vectors. So let's get these 2 vectors. Let's call these things A, B, and C. And let's see, I'll put C right here because I think that'll make things easiest. And then here's B. So this first thing, we'll call this U and this V. So my vector U, which is from C to A, is going to be the vector 1, 1, 1. That was easy enough. I just did the difference here. I started at C, ended at A. So you take the point A, subtract off the point C. Anyway, let's do the same thing for vector V. Start at point B, or start at point C, go to point B. So we're going to take the point B and subtract off the point C, and that'll give us the vector. So -1, 2, and -4. Now we do the cross product of these to get my normal. So the normal is going to be U crossed with V. So let's see if I can do this. I'll just kind of, here, let's see. Actually, I'm going to have to copy it down. I'll blow it up in just a sec. So I've got U and V. Okay, there it is. And I'm going to do the determinant of this matrix. So let's go ahead and copy the first 2 columns down next to all of this. And then we'll do our diagonals. So I'll just do it like this because I don't want to mess this up too much. So this down diagonal is 4i, -4i. This is -j, and this will be 2k. And then I'll do the up diagonals. Here. The first up diagonal is -k. I'll put them over here. And then plus 2, well, too late. 2i, positive 2i, -4j. Okay, so remember the program. We do down diagonals first and add them together. Then subtract off the up diagonals. So minus -k minus 2i minus -4j. There, kind of fit. Oh, it's up above my head. There, that works. Now it's right in my skull. Okay, so then now I can write down my cross product. I guess I should put it right. I'm going to put it underneath all this. So this will be equal to, let's see, -4i minus 2i is -6i. -j minus a -4j is plus 3j. And then 2k minus -k is plus 3k. So there's my normal. Maybe I'll do that to make it look more like a normal. Now all that's left is to take this along with this point, and we're going to come up with the equation of the plane. So -6 times x minus 0. I'm always doing this. You know, I'm going to bump into myself. I can see it coming. Just a minute, I'm going to erase that and start further over to the left. Let's try again. Okay, so we have -6 x minus 0 plus 3 times y minus 0 plus 3 times z minus 1, all equals 0. And you can simplify this equation if you want. I left myself no room. It's okay. You can do it yourself. It's not bad algebraically. So that's the way you do equations of planes. Um, so I know you're going to have some questions on the homework. There's some other planes, like it'll ask you for a plane that results from the intersection of two lines or something. Just go ahead and write them down and bring them to class or send me email. I'll do my best to help you out.